see projects from our class at RISD called Brainstorm Production Lab. These are works in progress. They're actually projects that are going to be finished at the end of the semester, but because of the timing, this is when we have the opportunity to share them with you. So I think the first one up is going to be Fabiana. Yeah, you should just come up and talk, yeah.
Hi, I'm Fabiana. My piece is actually outside, so maybe as you leave, you can take a look at it. But I was interested in the idea of learning through movement, and the idea that through the act of moving, your body and your mind is actually learning something. So I've been making markings based on movement and repetition, and trying to use these markings that are kind of one-to-one markings from the body as a way to kind of document how one learns over time. And I've been teaching different steps to non-dancers, ballet steps from pirouettes to port de bras, and kind of marking them as I go to kind of have an understanding. And the piece is outside as an installation piece. It's a work in progress, but it's showing this idea of how a releve changes over time and goes into a port de bras, and how it becomes more precise and more and more easy and automatic through this repetition and through this learning. And now I'm interested in kind of taking this vocabulary of markings that I've made and create a three-dimensional space with it to kind of engage the viewer to see the process of learning, so that the releve, your eye follows it and follows it into the port de bras, so it can start to talk about creating three-dimensional space through these movements, and that these markings can be used to teach dance or to understand how one learns, and in the end, hopefully, to create dance pieces or dance notation and create space through moving. You can see it on outside. It's right in the corner and on the floor.
If anyone would like to come in, there are a few empty seats. If you want to take a moment at this juncture. Everyone's good? All right, so our next presenter is Jess.
So the project that I'm working on is a series of spoken word pieces, exploring my experience with stuttering and how it's like directly related to stage fright. And the first one that I'm gonna perform to you guys tonight is a poem that like stem from my research in stuttering and a lot of like historical figures who have gone through stuttering, and relating that to my own experiences, to how I ended up overcoming stuttering. So without further ado, here's my piece. It's called Stammer. There's a creature inside my voice box. It trembles in the dark and tries to seal up the lid until no sound comes out. We call him a stutter. 300 BC, ancient Greece. Demosthenes was the greatest orator of his country. With pebbles in his mouth, he would shout his speeches at the roaring ocean wind. He would not let his stutter win. 200 AD, ancient Rome. Balbus Blasius' voice was an earthquake of stutters so large it carved him a place in the Circus Maximus. Encaged in the eternal shiver of his own bowels, the civilians lined up one by one to watch the coin-operated stutterer trip on his own words. 17th century Europe. The doctors thought it lived in tongues, lips, and necks, so with surgical knives they slit tongues, bore holes in necks and tonsils. They did not succeed in killing the stutter. Instead, they killed speech. 1865, Oxford, England. With each stammer that escapes from Lewis Carroll's lips, his dream to become an Anglican priest inches further and further away. With broken syllables running down his body, he dreams of a life where his stutter did not exist and wrote his way into Wonderland. 1992, Calgary, Alberta. Caught under the blur of all those names, I was born. I am no coin-operated stutterer. My parents have not yet heard me speak, but when they do, they will wonder why I stumble on my sentences the same way I choke on baby food. 2001, Seattle, Washington. It's my first day of elementary school. I was connecting ceiling dots into constellations of Cygnus and Cassiopeia when the teacher looks at me and says, "How many miles is the Earth away from the sun?" My knees buckle like vocal cords pulled too tight around my body. 93 million, I begin to say, but the words are light years away from my mouth, syllables slipping out of orbit. My larynx tightens with the force of some unknown gravity, clenching all the muscles inside me. The tectonic plates in my voice box shift sound into stutters, shivers, and quivers, leaving the remnants of an answer lost in a vortex of stammers. They just stare, crushing my tiny body with 20 pairs of elementary school eyes. One student's laughter invites others to join into a cascading crescendo of voices, more fluid than any broken record sound that would ever fall from my mouth. They call me Jessie, the stuttering stump, and finish my sentences for me. I feel the flames of embarrassment rise in my cheeks, a conflagration of unsaid words singeing the roof of my mouth. But bodies have no fire escapes, just tiny holes where the heat escapes, deep breath after deep breath, exposing anxiety into steam. The bell rings, and as if pulled by invisible threads of gale-storm winds, I am dashing home. I am rasping on a four-post bed. I am dreaming of Demosthenes trying to speak over pebbles in his mouth as though they could kill the stuttering creature inside. But we both know inside that being unable to speak is like being unable to breathe. And I know that no pebbles nor screams could ever drown out our stutters. These tectonic plates crash into our sentences with the might of earthquakes, strong enough to disintegrate all we have to say. But when they crash, mountains are born, and poems climb out of the cracks of our synapse. And those poems wrap their smooth syllables around me until I am no longer shaking, until I open the lid of my voice box with my bare hands and unearth the stuttering creature inside. Like a tea kettle on high boil, it was shivering and afraid of me, just as I was of it. I look at it and whisper, "From now on, I'm no longer scared. We're gonna work through this together." 2011, Providence. Today, if I could rewind these years back to the scratch desks of elementary school, if I could become one of the children who sat at Lewis Carroll's feet, I would have told them all. We're all scratched somewhere, but mine just show on the outside. I was never actually shy. I'm just an extrovert trapped in a stuttering shell. Maybe I was stumbling over my sentences because there was no words to express what I wanted to say anyway. There isn't a word for suffocating in unsaid sentences, or a word for forcing ourselves to speak against the odds of history. In this one-act play of life, there are no intermissions. The only way to overcome the stutters of stage fright is to hold your breath and dive headfirst into the spotlight.
Say it!
Thank you. So next we have Megan.
It's not the most remarkable feat of engineering yet. It's still kind of in its beginning phases, but I'm doing a neural mandala. And for whoever is not familiar with the mandala, it's been used traditionally for centuries in Eastern practices of spirituality, and the idea is basically that you can enter, not that these are the traditional mandalas, but that you can enter from any side, and it's just it doesn't matter where you enter from, but you end up at the center. And I think that the structures of the brain are a really good source of imagery for mandala, because we have first of all, we have the two hemispheres, and they join at the corpus callosum, and the first image was actually a potassium ion channel, And it's just, I mean, it looks like it came right out of the hand of a Tibetan monk. It's just, it's a simulation, but it's just unbelievable. And so what I want to do is, it's sort of an origami also, but I'd like to start from one of the smallest structures, which is the potassium, which is ion channels, and then move out to the larger structure of the brain. And you just see these structures repeating themselves, and I think it's a really nice metaphor for everything, because I don't think that repetition or that self-similarity ends at the skull. I think it's a nice thing to meditate on, to go from the level of your molecules right out to as far as you want to imagine. So this might not be as graceful as I'd like it to be. So yeah, it's just the beginning, but that is the ion channel, and then it's just going to go out, and then I'm going to have the structures themselves repeating, or the imagery repeating. And actually doing it is it's really meditative in itself, and I would recommend it to anyone. Just making this chipboard origami is not meditative, for the record. Yeah, so.
I'm studying sculpture and animation at RISD with junior. But I'm really interested in puppetry, so that's kind of the approach that I'm taking. I was really interested in the structure of the neuron, so I'm working on a neuron puppet, and I'll show you my prototype, and then I'll sort of tell you where it's kind of going from there. My lovely assistants, Sean and Megan. Sorry, just a minute. Really interested in so the idea of strings and how they can kind of be tangled and the different. I'm interested in how it gets tangled. I'm interested in sort of the similarities, not only the visual connection to dendrites in the neuron, but also that it is kind of like I don't know, maybe it's kind of a heavy-handed, silly metaphor, but just that it is like sort of this untangled thing that we're trying to understand. kind of going. I'm still sort of working out the kinks of it. I realize there's some things like just the functionality of it. The accent's a little heavy, so I need to work on that. Also, the controller for this part it needs to be a little shorter because he's already coming down like this. And I'm also adding LEDs. There's some LEDs that are already on it, not functioning yet, but it would be more of a spectacle with the LED lights kind of demonstrating the synapses. They would light up. Each puppeteer would have a controller. The switch would be here that would sort of ignite the synapses at the end of the dendrites. And then so the body of the cell would glow as well.
Our co-teacher Steve is gonna introduce the next project.
So, I'm Steve Sabanek, one of the co-teachers in this class, and the student who made these drawings can't be here tonight, so I thought I would just introduce him to you. His name is Odera Ibokwe, and he's an illustration student at RISD. And his interest in this course has been to develop characters and possibly narratives based on 4 different types of neurons. So he's developed these 4 characters. One of them is uni, based on a unipolar cell. Second is bipo, based on a bipolar cell. Third is multi, based on a multipolar cell. And the fourth is Pirod, based on a pyramidal cell. So he looked at the structure, the actual physical structure, visual representations of these cells, and then used his own imagination to develop characters based on their structure. At the beginning of the process, his primary concern was to develop their personalities. So. The way he interpreted them was that the unipolar cell was very simple and vulnerable, and then the bipolar cell I think was more like a worker bee, more functional, focused on a specific task. The multipolar cell was more of a like an executive function, controlling the other cells, and then the pyramidal cell, was very distant. Sort of, he used the term like a queen bee, sort of in the distance, very distant, but having ultimate control over everything that's going on. So he's developed now a sort of hierarchy of these characters. And he's in the process of now exploring the relationships and beginning to develop narratives on them, narratives about them. So these are some of the color illustrations that he's come up with. All right, that's.
So next we have Sri and Sam, the vital signs.
I'll talk about it. Cool. So the idea behind this project was discovery. We discovered this thing called the wire map, which is basically an object that is made up of many wires, you can see here, each one being its own small projector screen, mapped out in a program that describes the space, the real space that they're in, and in doing so, you can actually create forms in the wires. So it's kind of a 3D imaging process.
Yeah, so this is just a plexiglass structure with constraint. There's no electronics. It is held up by magnets, and we can move these around to calibrate. So basically what I'm doing is I'm using a projector here, and the projector, well, what the projector does when it's hooked up to my laptop is going to project the image that's on my laptop through this field. So what I'm going to do is instead, I'm going to project a set of vertical lines that are calibrated to exactly where I want. And by animating those, I can give the sort of illusion of a 3D volumetric animation display. So let's see. Just gonna cycle through these. So, if I don't have to leave early, I'll leave this on and you guys can walk around this. Really quite cool. So right now we're using 64 wires. The next plan is for us to use 128. The biggest that this has ever been built on by its original creator, who we talked to for advice to build this thing, used 512. In which case, since the computer screen is 1024 pixels, that means every other pixel on the computer screen would be mapped to an independent string, and that would be quite a task. So I think once you get to 128, you actually have enough strings to get some pretty high resolution images on here. For example, Sam was just talking offhand, you could even have an image of a tree branch going outwards, and you would have enough strings for it to look three-dimensional, but in reality the image is actually just a set of vertical lines on my computer. So the plan is to connect this with EEG data from sleeping patients. We were going to hook up a gyroscope. Do you want to talk about gyroscope stuff?
So in terms of visualizing the EEG data, we were going to give the user control over how it's being treated by making an alternative MIDI controller. And if anyone doesn't know what that is, it's just a computerized way of sending a musical command. And what it can do is it can control sound. And so you can rewind, fast forward, up the volume, up the resonance on wave files, sound files, that are actually made up of this EEG data. And when I say that, what I mean is that the waves, instead of being brain waves, are now sound waves. The good thing about that is a layperson, like you and me would, when they're reading data, not any idea what to do with it or how to read it, but as soon as you put it in, first of all, 3D place like this, you start to form new relationships, as well as when you hear it as sound, you start to form new relationships. And so we're going to take an Arduino and a gyroscope, two pieces of technology that allow us to measure rotation and tilt, and we're going to give the user control over how they experience the sound by making it control the music and the visuals.
So we'll make a composition using EEG data. If you guys are not familiar with what EEG is it's a way of measuring brain signals, essentially, by placing electrodes on the scalp, and that will read in the brain waves that are going on while the person is asleep, and that will be recorded onto like a graph, sort of when you see earthquake data, like you see the waveforms form from that. Similarly, we see the same thing from a sleeping patient. So we'll take that and we'll create a sound out of it, because anything that has a vibration frequency can be turned into a sound. And then we'll move this into a range where the human can hear it, and then create some sort of musical composition using this. So the musical composition is itself made from brainwaves from a sleeping patient. And then we'll give somebody a box that we'll construct, and while the music is playing, you'll be able to move around this box, and you will see the image on the wire map and the sound change in live time. So suppose maybe you tilt it forward and you hear the sound tilt upwards and then tilt downwards, or pitch bend. And
This is one that simulates.
I'm actually really excited about this studio because I am dual enrolled as a student at Brown, where I am majoring in neuroscience, as well as at RISD, where I am majoring in painting. So yeah, I'm really excited that there's a studio class about neuroscience. So as a student of neuroscience, I spend a lot of time sort of in dialogue with textbooks that are filled with really cool images of brain processes, and then a lot of how we learn these through these diagrams that describe really, really beautiful processes that are complex, but often I find that the diagrams are not quite as beautiful as the process that they're describing. So what I've been exploring a little bit has been through drawings, sort of getting the information across, yet also starting to capture some of the poetic beauty that I feel come through these. So this is depicting one process in particular, and it's basically the process in which neurons they package their chemical messengers called neurotransmitters that they're getting ready then to send off to other neurons, and that's one of the major ways that they communicate. So this is just kind of showing the process.
Okay.
Yeah, no, it's fine. And then there are more complicated structures that I'm representing through lines and dots that a lot of textbooks will just kind of use very sort of dry dotted lines and things. Next one. And then this is what these actually look like. This is imaging, basically like pictures. They're the closest thing we can come to pictures of these structures. And as you can see, they're quite beautiful on their own. So again, it's a task of getting that sort of diagrammatic or schematic information across, yet also getting sort of the beauty that an image conveys. So, and this is an example of a diagram this is technically representing that picture we just saw, which as you can see is just not quite as beautiful, yet the information that it's portraying is beautiful. It's that little sort of three-armed thing is a protein, and a bunch of those proteins come together to form those sort of lattice structures that you were seeing. So you can go to the next, which is kind of like, this is my interpretation sort of the previous diagram that we just saw, that has more of kind of the powerful beauty that comes from such a ubiquitous process that's so important to neurons and functioning.